Hello guys, myself I'm Marin Muslim. I'm studying history at Prashar College of Engineering and I'm belongs to Chanakya section. Today let us discuss about TBMS, Relational Model Concepts. The relational model is a fundamental concept in database design. It represents data as a collection of tables, where each table consists of rows and columns. This simple yet powerful approach allows for efficient data storage, retrieval, and manipulation using the structured query language. Entities and attributes. Entities in the relational model. An entity represents a real-world object or concept that we want to store information about. An entity can be a person, place, thing, or event, such as a customer, a product, or an order. Attributes. Attributes are the individual pieces of information that describe an entity. For example, a customer entity might have attributes like name, address, phone number, and email. Attributes provide the detailed data that characterizes each instance of an entity. Relationships and cardinality. One relationships. In a one-to-one relationship, each entity instance in one table is associated with at most one entity instance in another table, and vice versa. This is a rare scenario but can occur when two entities are highly interdependent, such as an employee and their employee ID card. One-to-many relationship. The one-to-many relationship is the most common type where one entity instance can be associated with multiple instances of another entity, but each instance of the second entity is associated with only one instance of the first. For example, a department can have many employees, but each employee belongs to only one department. Many-to-many relationships. In many-to-many relationship, multiple instances of the entity can be associated with multiple instances of another entity. For example, a student can take multiple courses and a course can have multiple students. These complex relationships require a joint table to properly model the connection between the two entities. Relational model constraints. Entity constraints. Relational model impose constraints on the entities within a database, such as ensuring that each entity has a unique identifier and that all attribute values conform to the defined data types. Relationship constraints. Relational models also define constraints on the relationships between entities such as cardinality, one-to-one, one-to-many, many-to-many, and referential integrity, ensuring that related entities exist. Domain constraints. Relational models allow for the definition of constraints on the allowable of the attribute known as domain constraints. This ensures data eligibility, integrity, and constraint stability. Domain constraints. Key constraints. Key constraints are fundamental rules that define the structure and integrity of a relational database. They ensure the data stored in the database is consistent, accurate, and meaningful. The primary key constraints is a unique identifier for each row in the table, guaranteeing the uniqueness of each record. Foreign key constraints establish relationships between tables, enforcing referential integrity and ensuring that data in one table is properly linked to corresponding data in another table. Additionally, entity integrity constraints ensure that every table has a primary key and that the primary key values are never null. These constraints are essential for maintaining the consistency and reliability of the data, preventing duplicate or incorrect information from being stored in the database. Referential integrity. Referential integrity is a crucial concept in a relational database design that ensures the consistency and accuracy of data across related tables. It is a set of tools that govern the relationships between tables, ensuring that the data in one table is properly referenced and validated against data in another table. This helps prevent offhand or dangling data, where a record in one table refers to a non-existent record in another table. The primary mechanism for enforcing referential integrity is the foreign key constraints, which establishes a link between the column in one table and the primary key of another table. This constraint ensures that any values entered in the foreign key columns must match a valid value in the referenced primary key columns of the other table. This may occur in the relationships in between the data and prevents the creation of the referential integrity. Relational database schemas. A relational database schema is the blueprint that defines the structure of database. It outlines the tables, their columns, data types, relationships, and constraints that govern the data stored within the database. This schema provides a clear and organized way to manage and assess the information, ensuring data integrity and consistency across the entire system. The schema typically includes entities that represent real-world object or concept and the attributes of the income that describe the characteristics of those entities. The relationships between these entities, such as a one-to-many or many-to-many, are also defined in schema, providing a clear understanding of how these are happening and interconnected. Normalization principles. Eliminated redundancy. Normalization aims to remove duplicate data and eliminate redundant information across tables. This improves data integrity, reduces storage requirements, and ensures consistency throughout the database. Established dependencies. Normalization establishes clear relationships and dependencies between data elements. This allows for more efficient data organization and retrieval, as well as better support for complex queries and reporting. Minimize anomalies. Normalization minimizes update, insert, and delete anomalies that can occur in denormalized database designs. This improves data reliability and ensures the integrity of the information stored in the database. Normalization principles. Database normalization is a crucial process in relational database design, aimed at reducing data redundancy, improving data integrity, and optimizing database performance. The three principles of normalization including eliminating repeating loops, ensuring full functional dependencies, and removing transitive dependencies. By applying normalization techniques, database designer can transform a relational schema into a series of well-structured tables, each with a unique primary key and related through defined relationships. Normalization principles. Normalization principles database design technique that organizes the database to reduce redundancy and dependency. The goal is to isolate data so that additions, deletions, and the modifications of a field can be made in just one table and then propagate data throughout the rest of the database for the defined relationships. The main normalization principle include one, eliminating repeating groups, two, ensuring all attributes and the dependent on primary key, and minimizing transitive dependencies.